2, 1.
Okay, this is one of the first things I teach whenever anybody's coming into engineering. You'll find this will be the first thing that is covered if you're taking a college level biology, chemistry class. Same with electronic engineering. You must know your metric notation. I wish that we were on the metric system, but we're not here in the States. So, you know, it's like you gotta relearn some of the basics, and you'll hit it in any class. So I have a unusual way of teaching this. I'm a visual learner, and for some students where, you know, working mathematical calculations with exponents isn't working out for them, I show them my way as another way to learn number and unit conversions. Hopefully this will work out. I'm not sure how this is going to play, if it's going to go too good on the electronic whiteboard here, but we'll give it a shot. Okay, so I'm just going to start. When I start teaching this lesson, I always start at what I like to call ground zero. And that is a terrible arrow, but that's an arrow. It's an arrow. So I call this ground zero because if I was going to write a zero or denote a zero, I would put it here in this space. Okay, so I start here in the ones position, and I start from the left of the decimal, so I can lay some groundwork, some things that people hopefully are familiar with, like you know, once you get past the 100 number, or once you get past the hundredths, you're into the thousandths represented by kilo, then into the millions represented by mega, and then into the billions represented by giga, as I've laid out here. Kilo, mega, and then giga. So this is how I do number conversions. Typically electronics calculations will fall between mega and nano, but sometimes you get into the pico range. So if you know kilo, mega, giga, and milli, micro, nano going to the right of the decimal, you're usually going to be okay in my class. You notice for every position from the ones position to kilo, mega, and giga, I've got 3 spaces. This is because in electronics engineering you deal with engineering notation, and engineering notation moves by exponents of 3, or 3 places at a time. So this is why I've got a dot between each, the ones position, the kilo, the mega, and the giga. Because of engineering notation, it moves in factors of 3. So to clarify, in engineering notation, the decimal moves in 3s, okay, 3 at a time, every time. So let's say we have the number 100, and we're going to give it a value of ohms. Let's say we have 100 ohms. All right. So if I was to write the number 100 here on my little chart, I would put it here. Once I lay the groundwork, I like to ask my students this question, or questions like this. 0.67 mega ohms is how many kilo ohms? Okay. Now keep in mind I said 0.67 mega ohms. All right. So we find the decimal point for mega, which is here, and then we say, okay, 0.67 mega ohms. I'm going to write that in. 0.67 mega ohms. All right. And the question was, how many kilo ohms is that? All right. Well, here's the decimal point for mega, and here's the decimal point for kilo. So I want to convert to kilo. I need to fill in all the zeros up till the decimal point. So 0.67 mega ohms is, I'm going to fill in that 0, 670 kilo ohms. Okay. I'm hoping this is another way that you can make those quick calculations in your head, you know, if you don't want to do the math. All right, so I'm going to do one more here. That one again was 0.67 mega ohms converted to 670 kilo ohms. So we're going to say for our next one, all right, 0.02 giga ohms is how many kilo ohms? Okay, so I'm going to find my decimal point for giga, which is right here. So 0.02 giga, 0.02 giga is how many kilo ohms? All right, well again, kilo is over here, So I need to fill in all those zeros. So 0.02 gigaohms is 20,000 kilo ohms. And again, like I said, no one's going to note it like that because that's pretty much like saying that's 20,000 ohms. But the truth of the matter is that's still correct. It's 20,000 kilo ohms. Okay. So again, it's just about filling in the numbers to the decimal point. So for those who are visual, you know, if you can picture this chart in your head, all it is a matter of filling in zeros, and it cuts time for calculations and conversions. Just you can do them on the fly. Don't need to write anything down once you get this memorized. So I'm going to flip over to the other side of the decimal point where we'll work some milli, micro, nano, and we'll pick up from there. All right, so here we are on the other side of the decimal point. What you might find interesting is we're working number conversions without really having to work exponents. I've chosen not to include the actual exponent calculations like milli, -3, micro, -6, nano, -9, and pico, -12, because I want to show you a visual way of learning it without the numbers. All right, hopefully your textbooks or your other professors will fill in the rest of the gaps for you, if there are any. I showed you how it worked on the other side. We're just going to do the same here. In this case, if I was to write the number 1, it would go here. So this is the main decimal right here that's going to separate my numbers greater than 1, which are over here, from my numbers that are less than 1 over here. Okay, so dealing with numbers less than 1. So let's say you were given 100 micro is how many milli? All right, well, we have to find the decimal place for micro. Okay, that's for milli, that's for micro, that's for nano, and that's for pico. All right, so if I say 67 micro is how many milli, so we need to find the decimal point for micro. It is right here, and we say, okay, 67 micro. If I'm going to write 67 micro, it's got to be right here. Okay, so that is 67 micro, right on the decimal point. All right, and the question was, how many milli is that? All right, well, the decimal point for milli is to the left, and it's right here, so we need to fill in the 0. Okay, so again, the question was 67 micro was how many milli, and again, we write 67 micro, 67, and then find the decimal point for micro right there, and then ask ourselves how many milli is that? Well, milli's right here, so we fill in the zeros. 0.067 milli is equal to 67 micro is equal to 67,000 nano is equal to 67 million pico. Okay, so that's all this is as far as conversions go. It's just a matter of moving it's just a matter of filling in zeros till you get to the decimal place of the point of what you want to convert. All right, so some people do it in their head by manipulating exponents. I do it in my head by putting zeros on a chart. So let's do another. 13 milli is how many nano? Okay, so here's milli, so I'm going to pencil that in right there. 13 milli, because that's where the decimal point is for milli, is how many nano? Well, nano's over here, so we got a lot of zeros to fill in. 1, 2, 3, 4, 5, 6, and you'll see that 13 milli is 13 million nano, or 13,000 micro, or just 0.013 whatever unit. Okay. I hope that helps. Again, it's not my intention to confuse. I know it's a unique way of learning this. There may be other methods out there that are similar. This is just how I do it because I'm a visual person. I'm not going to try to add -3 to 6 or not that that's hard, but it just not that that's hard, but I find the translation works so much faster, so much quicker for me in my head if I just have this chart in there. So again, a few things you would have to just remember. You just have to remember milli, micro, nano, and usually when I teach my students, I just say that repeatedly until it sticks. Milli, micro, nano, milli, micro, nano, milli, micro, nano. All right, and then beyond that you have pico and femto, etc. But milli, micro, nano will get you through 80% of the calculations that you will need in the class. So if you get pico and femto, all the better. All right, again, comment with any suggestions, like the video if you like it, subscribe, and we'll talk to you next time.